Welcome and thank you for attending today's Enterprise Tech Journal hosted webinar. This is Denny Yost with Enterprise Systems Media and your host for today's webinar. To send us a question during the webinar, please click on the chat bubble icon on the left side of your screen. That will open the chat window, which in this case is only being used to send us your questions. Joining us today from Logon Software is Mark Scora. Mark will be explaining how QuickSelect for Db2 and IBM Db2 Analytics Accelerator provide complementary approaches to Db2 performance acceleration. At this time, I will turn the floor over to Mark.
Hello everyone, and thank you for joining today's webinar. Today we'll compare and contrast two powerful and complementary solutions for Db2 workload performance acceleration: Logon's QuickSelect for Db2 and IBM's Db2 Analytics Accelerator. If you're familiar with IDAA, but not yet with QuickSelect, I think you'll find this both interesting and valuable. My name is Mark Scora, and I'm with Logon Software, a provider of innovative solutions for the mainframe. I'll present today without pause, but please feel free to enter questions in the chat window during the presentation, and I'll address them at the end. For any additional questions you may have in the future, please feel free to reach out to us at ask@log-on.com. Okay, let's start by discussing some common Db2 performance objectives I think any large organization can relate to. The desire to improve online application performance, batch job throughput, reducing CPU consumption related to the Db2 workload, reducing physical I/O related to the Db2 workload, and of course getting more work out of your existing Db2 resources. And what are the barriers to achieving these common objectives? Many approaches promise performance gains and reduce CPU consumption. SQL tuning, application modification, batch process tuning. What do they all have in common? Big projects, long learning curves, a big investment of time and money, and a long time to the return on investment. Now let's discuss our two plug-and-play approaches: QuickSelect for Db2 and IBM Db2 Analytics Accelerator. Let's start this comparison by taking a look at the distribution of SQL across a typical Db2 SQL workload. As we can see, most SQL take only milliseconds of CPU to execute. These are the simple queries and in general were optimized long ago. In most shops, they will not be looked at as opportunities to improve performance or save CPU. It's assumed that nothing more can be done with these. The focus instead is typically on the elephants, those SQL that consume a lot of CPU and take a long time to execute. Many of these elephants are complex SQL for the analysis of large volumes of data. Think data warehouse queries, online analytical processing. Some time ago, IBM got smart about this part of the workload and realized it was more efficiently processed outside Db2 using specialty hardware. They purchased a hardware engine for this called Netezza, now called IBM Data Analytics Accelerator. So let's highlight the capabilities of IBM's Db2 Data Analytics Accelerator. As mentioned, IDAA is designed to move heavy OLAP and analytical SQL processing off the Db2 engine. It's a plug-and-play appliance, albeit a hardware-based one, whereas QuickSelect for Db2 is a software-only appliance. IDAA seamlessly extends the capabilities of Db2. Data is copied from Db2 tables, not moved, and all of this is done with full data integrity. We'll come back to this overview of IDAA in a few slides to compare it and contrast it to QuickSelect. But for now, let's go back to our fast-running SQL. You'd likely never consider an SQL that consumes just 15 milliseconds of CPU a prime opportunity for improving performance and saving CPU. But if that SQL runs over 10 million times a day, it's consuming over 4 hours of CPU. If we can save on these SQL, we have a big win. If we take a close look at these simple, fast-running SQL, we see that many of them ask for the same result sets over and over. These are the annoying mosquitoes of the workload, as we like to call them. They're irritating in small numbers, but large swarms can do quite a bit of damage. QuickSelect is designed to deal with these repetitive SQL, just as IDAA deals with the elephants outside Db2. QuickSelect greatly reduces Db2 overhead associated with the mosquitoes by dealing with them outside Db2. Again, QuickSelect services repetitive selects outside Db2. It's a plug-and-play appliance, in this case software only. Just like IDAA, it seamlessly extends the capabilities of Db2. Data is copied from Db2 tables, not moved, and all of this is done with full data integrity. So let's compare QuickSelect to IDAA. The key point is they both accelerate components of the Db2 workload, but they work on opposite ends of the workload, with IDAA focusing on heavy OLAP and analytical SQL, QuickSelect focusing on simple repetitive SQL. The two solutions are fully complementary, do not interfere with one another. IDAA is a hardware utility, QuickSelect for Db2 is a software utility. IDAA copies data from Db2 into a backend for very fast processing. QuickSelect copies frequently requested result sets from Db2 into its own cache for very fast retrieval. As we can see again, the two solutions are not just similar, but they're also highly complementary. Let's discuss how QuickSelect and IDAA play together. QuickSelect catches the mosquitoes before they reach Db2. All other Db2 queries pass right through to the Db2 optimizer. The optimizer detects the elephants, those queries suitable for processing by IDAA. It passes them along to IDAA. The optimizer in IDAA do not know or care about the mosquitoes caught by QuickSelect. Let's take a quick look at real-world QuickSelect savings. These are actual numbers from a large commercial bank. In this particular Db2 subsystem, executing on average 4.6 billion SQL per day, QuickSelect avoided the execution of 31% or 1.4 billion of those SQL against Db2, instead serving those result sets directly from cache back to the applications. Let's discuss another key QuickSelect concept, that of result set caching. Let's take a given SQL statement, select price from product, where product ID equals a host variable. Unique instance of this SQL statement would be the statement plus a unique given host variable. A unique SQL instance returns a unique result set. Simple concept, but one that is key to the way QuickSelect functions. Let's take a few examples. Select price from product, where product ID equals SKU1, result set equals $1,541. SKU2, result set equals $24. SKU3, result set equals $546. The result sets are what we are caching. We are not caching data. We are not caching tables. Again, we do not cache tables. We only cache result sets. We only cache repetitively requested result sets. Cache is dynamically populated in real time. Why do we cache only repetitively requested result sets? Unless we can see that a result set has been requested, let's say 3 times, we can't assume that it may be requested a 4th, 5th, and a 6th time. So this is all about caching efficiency. Let's visualize what QuickSelect does in motion. Our components, Db2 database, QuickSelect cache, the QuickSelect server, and our Db2 DSN XLI. A program issues a query. The DSN XLI is the point of QuickSelect interception. QuickSelect will determine whether that SQL is eligible for caching based on certain thresholds that are set in the parm_lib. If it's eligible for caching, the SQL is passed along to QuickSelect. QuickSelect will then determine whether or not that result set already exists in cache. If it does, the result set is immediately retrieved from cache and passed directly onto the application. If that result set is not in cache, QuickSelect will start to count the number of times it sees that specific result set. When it reaches a threshold number of perhaps 3 repetitions of the same result set, that result set will then be cached for future retrieval. Let's review what we mean by QuickSelect being a plug-and-play solution. In short, you don't have to change your application code. You don't have to recompile. You don't have to rebind your SQL. No changes are required. This is important. People don't want to have to touch their programs. Once you do, there's testing. It's very time-consuming. It's expensive. It's risky. If you have batch jobs to invoke QuickSelect, you don't have to change your JCL. We catch the batch jobs on the fly. Finally, QuickSelect is so non-invasive that you can turn it on and off while it's caching in production with no impact to your operations. Turn it on, turn it off, turn it on, turn it off. The only difference is going to be whether or not you're caching your result sets and achieving your savings. Let's discuss another key QuickSelect concept, that of the fact that QuickSelect ensures full data integrity. No dirty reads, no data integrity issues. Cached result sets will always mirror those that would be returned by Db2 itself. QuickSelect is update sensitive and utility execution aware. Either of these activities will cause QuickSelect to immediately invalidate the associated result sets in cache. SQL statements that update trigger invalidation. Db2 utilities that update trigger invalidation. Let's discuss some additional QuickSelect basics. QuickSelect has a front end that checks to see if a statement is eligible for caching or not. We do it once for each SQL. Once we've analyzed an SQL, we'll mark it in our memory. If the SQL has anything to do with updates, deletes, or inserts, we'll always immediately forward it to Db2 for processing. It's not for us. We're only about reads. QuickSelect stores its cached result sets above the bar. It's not encroaching on any memory that other tools or that ZOS needs. QuickSelect manages its cache dynamically. You allocate a certain amount of cache. QuickSelect will actually use only what's needed, and cache sizes tend to be relatively small. We don't store a lot of data because we're only caching result sets, not tables, and we're only caching result sets that are frequently requested. You can have members of the same Db2 Plex running across multiple LPARs, and will provide caching across the Plex with full data integrity. You can have one member on one LPAR and another member on another LPAR serving exactly the same database for enhanced performance across very large workloads. Finally, QuickSelect provides a survey mode that's very useful in identifying SQL suitable for caching and in projecting potential savings for QuickSelect prior to actually turning QuickSelect on in cache mode. Survey mode is typically the first step in a proof of concept, as it allows you to project return on investment without actually having to cache. A question we're frequently asked is, I have all of my data in buffer pools. Db2 is fast. Why do I need another cache? And the answer is, it's all about relative code path length. Db2 SQL code path lengths range from 30,000 instructions at the very low end to 25 million and up. Here we see a query that is executing 1.39 million instructions. Obviously a very long code path length, even when the needed data is already in Db2's buffer pool. By way of contrast, QuickSelect implements a very short code path length, in no small part because Db2 has already done all of the heavy lifting required to generate the result set that QuickSelect caches. All QuickSelect has to do is cache, retrieve, and serve. So a key concept worth repeating, QuickSelect intercepts, caches, and returns result sets. It does not generate them. It is not a DBMS. It avoids the hard work done by Db2, simply borrowing the result sets generated by the hard work that Db2 does. Another frequently asked question is, what is QuickSelect's overhead? Probably the best answer is, don't worry so much about the overhead, but enjoy the net savings, because the amount of CPU that QuickSelect consumes disappears with respect to the tremendous CPU savings that it delivers. One part of QuickSelect that is directly measurable is that of the QuickSelect started task. You can measure this. It consumes a very small amount of CPU. QuickSelect also generates a small amount of overhead within the application itself. Again, here you can measure the net savings on average over time, and QuickSelect disappears into those net savings. Two more examples of real-world savings. Here we measure a 94% reduction in CPU consumed for SQL that meet our cache thresholds. Here we see that for the same workload, we've avoided 228 million hits against Db2, or 96% of those unique SQL. Here's another real-world savings example for a single QuickSelect program running at a major insurance company. Our vertical dotted yellow line demarcates QuickSelect caching off to the left and QuickSelect caching on to the right, with our yellow line indicating a decrease in get pages and our blue bars indicating a decrease in SQL executing against Db2. If we take a look at our table, we can see that our average daily count of SQL executing directly against Db2 decreases from 1.9 billion to 146 million, or 92.4% of those SQL are now being served by QuickSelect cache as opposed to consuming Db2 resource through repetitious execution. Likewise, our average daily get page count decreases from 27 million with QuickSelect off to 4.9 million with QuickSelect on, a reduction of 82% in I/O activity. Okay, we discussed the value that QuickSelect can bring to both your online applications as well as your batch workloads, improving performance and reducing CPU overhead and I/O activity. Let's talk a little bit now about what a typical proof of concept looks like. Proof of concept is based on running and analyzing survey reports. And as we discussed earlier, a survey is simply QuickSelect's refined process for capturing workload characteristics that are relevant to the types and quantities of SQL that are suitable for QuickSelect caching. Very low overhead. We identify candidate SQL based on threshold parameters, and from those candidate SQL, we're able to see the underlying tables that the result sets are derived from. Here a little bit of local knowledge comes into play. A DBA confirms those tables that are either relatively stable or are relatively frequently updated. QuickSelect prefers to cache derived result sets from relatively stable tables such as lookup, reference tables, cost tables, price tables, etc. The faster the table is updated, the more frequently the table is updated, the more frequently cache will be invalidated. And you do reach a point where the ROI turns upside down. Table doesn't have to be entirely stable, but we do prefer relatively slow update tables. Once those tables have been identified, the user simply adds these tables to a cache list in an ISPF panel, and from there can activate caching for the candidate SQL that derive the result sets from those tables. Survey can be run both with and without caching enabled. Why would you run it with caching enabled? You might want to run QuickSelect survey periodically, perhaps every 3 to 6 months, if your applications are being actively maintained and enhanced, to determine potential new candidates for caching and to add those to the cache list. Finally, a proof of concept delivers quantifiable results without having to actually turn on cache mode. So it's a great tool to very quickly see what the potential results from implementing QuickSelect will be in your environment. Let's take a look at a couple of typical survey reports. At the top, we're looking at a report that was generated during a proof of concept. As you can see, we're only looking at potential savings. This is for a 12-hour run that started at 6:15 in the morning and ran through 6 o'clock in the evening. And what this summary report shows us is that QuickSelect identified cacheable result sets derived from 29 different tables, that it identified 2.36 billion potential cacheable hits against those tables, that it would have taken 891 initial Db2 calls to arrive at the 2.36 billion cacheable hits. Why the initial Db2 calls? As you may recall, we want to see a certain number of executions of a given Db2 unique query before we cache that result set. Once we've seen, let's say, 3 repetitions, the result set gets cached. If we don't see 3 repetitions for certain queries, obviously those won't get cached. Thus our 891 Db2 calls. And finally, we can see the ratio of Db2 calls to cache hits. We can see that 99.96% of our queries would have been cache hits as opposed to Db2 calls. Very impressive results, not atypical. Down below we have a second report. We can see in the far right hand column that these are all cached result sets. So this would have resulted from cache mode being turned on to save. And once we're saving, we can see the breakdown of cache hits by, in this case, program, number of tables, etc. Again, very impressive results. Let's quickly review a few additional success stories, and here I'm going to let you read as opposed to reading through the slides for you. First relates to a large commercial bank with a large QuickSelect. And in this situation, QuickSelect improved Kix online performance, average transaction performance by 24%. Reduced total CPU consumption by 16%. Again, that's total machine consumption. Another large commercial bank, Db2plex and IMSTM online environment. A single application running across 4 LPARs with more than 10 billion SQL hits per day per LPAR. Typical cache hits in a 12-hour window were greater than 2 billion. Db2 calls avoided. As a result, they were able to retire a single LPAR and turn off the related CPU after implementing QuickSelect. This was their low-hanging fruit, their initial implementation. Large health insurance company with 15 Db2 subsystems. More than 5 billion SQL served from QuickSelect cache and not Db2 during peak batch cycles. Qlik's transaction performance was substantially accelerated. QuickSelect is a straightforward installation. It installs via SMPE. We include an installation verification program. You do the initial setup in a sandbox, and then you're able to clone QuickSelect via its own ISPF interface. We're always asked, what are the resources required for a QuickSelect proof of concept? Your system programmer to perform the SMPE installation and administration of QuickSelect during the POC and after acquisition. Db2 DBA to create required tables for QS operational data, to grant permissions, to review survey results to determine which tables are appropriate for result set caching. Of course, your site security special grants required permissions. And then an individual knowledgeable regarding the use of your on-site Db2 monitoring solution. This can be used during the POC to measure and extrapolate performance gains and CPU savings in test QA as well as production if you wish to take QuickSelect into your production environment during the proof of concept. This individual is going to be key in helping you to generate the ROI projection for the full implementation of QuickSelect. So in summary, QuickSelect returns the same result sets as Db2, but from high-speed cache, saving CPU and I/O, reducing elapsed time, and improving performance for both your online as well as your batch Db2 workloads. QuickSelect frees Db2 resource to better serve the rest of the workload. There's no complicated project, no SQL analysis, no SMF analysis, no big implementation project. QuickSelect requires no changes to your environment, no changes to application code, no testing, no changes to JCL, no changes to your databases. It implements very quickly for immediate return on the investment, designed for plug-and-play Db2 performance gains. Okay, I can see that we do have 3 questions that have queued up since the start of the presentation. The first one is, how do we set up processes to populate QuickSelect cache? Great question. Again, everything that QuickSelect does is dynamically managed by QuickSelect itself. There's no need to set up your own processes to populate QuickSelect cache. QuickSelect does this dynamically when you initially start a QuickSelect server. The server will start to observe the Db2 workload as it sees repetitions of suitable SQL that meet the threshold. Those result sets get populated into QuickSelect cache automatically. And in that fashion, the cache is built up incrementally until such time as the server is turned off or there's a change to the underlying table, at which point QuickSelect will automatically invalidate the cached result sets related to the updated table and start to build the cache up again. So again, no need to set up your own data population processes. All right, second question. How large is QuickSelect cache? Again, a great question because we're caching result sets and not entire tables. QuickSelect cache tends to be very small, usually around 2 to 5 gigabytes of physical memory per Db2 subsystem. When you set up QuickSelect, you'll allocate an amount of memory above the bar for cache. This allocated amount is not to be exceeded by QuickSelect, but if the entire amount is not needed, the balance is available to other users QuickSelect doesn't maintain a hold on the entire allocated amount of cache. Final question, what happens if we modify an SQL after we start caching? Again, a great question. There's a lot of learning that QuickSelect does in the background. All of this is hidden beneath the covers. One of QuickSelect's learning processes has to do with the modification of programs and associated SQLs. If an SQL is added to a program or modified, QuickSelect automatically picks up on this and will learn that SQL to determine whether or not its result sets are appropriate for caching. If they are, it will automatically start to cache those result sets. So again, no need for manual intervention. So, 3 excellent questions. I want to thank you all again very much for attending this presentation, and say that if you have additional questions or if you have interest and would like to discuss QuickSelect further, please reach out to us at ask@log-on.com, and we will be happy to get back to you. Thank you very much again.
Thank you, Mark, for your very informative presentation today. And thank you all for attending today's Enterprise Tech Journal hosted webinar. If you have any questions concerning today's presentation, please send an email to ask@logon.com. You can also visit their website at www.log-on.com. Bye for now, and we hope to see you in our next webinar.